Okay, welcome all to this online session of data structure. Today, our topic is queue data structure. So we are going to start the uh, queue data structure online session. So welcome you all for this session. So this is the part of the MCA syllabus for the VTU MCA syllabus, and it comes under the module 2, where module 2 has recursion and the queue. So we are going to discuss this syllabus based on the MCA syllabus. So here in the queue, we are going to discuss about the definitions, representation, queue agility, operations, queue variants, that is linear queue, circular queue, priority queue, double-ended queue, applications of queues, and programming examples. So first we'll see data structure classification. Data structure is classified as linear data structure and non-linear data structure. Whereas linear data structure is further classified as array, stack, queue, linked list, whereas non-linear data structure is classified as graphs and trees. Now where does this queue stand? So you can see the queue stands here, which is under linear data structure. So you can define queue as a linear data structure. Queue is a linear data structure. Now to understand queue, first we will see the queue in normal life. So assume these are the vehicles waiting for the toll gate here, and they have to go out. So the vehicle that comes first will be at the front. This is the second vehicle, this is the third, and this is the last vehicle. So rear will be pointing to the last vehicle. So we will call it as a rear vehicle, and this is we will call it as a front vehicle. Now, according to the rule of the toll gate, which vehicle should go out first? So it should be front vehicle, right? So in the system also, if we implement a queue, the front element is sent out first. So sending out means we call it as a deletion. Because sending out means it is deletion from the queue. Whereas the new vehicle that comes in here will be added at the rear of the queue. So it will come at the rear. So the insertion, so coming a vehicle is called as a insertion here. So new vehicle is inserted at the rear. So we can say here deletion is always done at the front end. That means vehicle at front will go out first, whereas insertion is always done at the rear end. So new vehicle will enter at rear. So this is how the system queue we can see. So you can see in this queue, front is shown in as a at the beginning here, and rear is shown here. So front is pointing to the element 7, which is at index 0. Okay, and rear is pointing to element 1, which is at index 4. Okay, so here if you have to insert data into this, then insertion is always done at the rear end. So insertion is also called as NQ, whereas the deletion is done at the front end. So deletion is called as a DQ. So Q, how you can define now? So Q is a linear data structure from which items may be deleted at one end called front. That means deletion is done at the front, and the items are inserted at other end called as the rear. That means insertion is done at the rear end only. So what are the properties of the queue? So you can say queue is also a ordered list. Now what do you mean by ordered list here? Ordered doesn't mean a sorted list here. Values need not be sorted. What does it means? Items contained in the list have specific numerical order. That means they are stored as per the index. So that means what? First element will go at the index 0. The second value that comes in the queue will go to the index 1. Third value that comes will go to the index 2, so on. So the values are stored as per the index. Hence it is called as an ordered list. Now it follows a FIFO principle. So FIFO means first in, first out. The vehicle that comes in first will go out first. So first in, first out. And NQ means it is inserting the element into the queue, and DQ means deleting an element from the queue. So representation, how a queue can be represented. So queue can be represented in two ways. One is called as array representation, and another is called linked list representation, or simply linked representation. So in the array representation, we use array itself to represent a queue. So queue is stored in array, and right now this queue is made up of 10 elements, that is 0 to 9. Total 10 elements are there, where first 5 elements have been deleted. So after deletion, the front is pointing to the 5th element here. Okay, so right now 10 is the first element as per these values, and 30 is the last value. So your rear is pointing to 30 and front is pointing to 10, and these are the indexes here. So this is how array representation, Q is represented in array. Whereas if you take the linked representation, in that we store the values in a node, where one node points to another node, and that node points to the next node, that node points to the next node. So the rear, we use a rear pointer here which points to the last node, and we use front pointer which points to the front node. So we require two pointers here. Front pointer points to the first node and rear pointer points to the last node. So here also the insertion happens at the rear end and deletion happens at the front end. So abstract data type. So we have to define the abstract data type for the Q. So as all of you know, abstract data type means it is a general data type which can be implemented in any language. Okay, once you define the abstract data type, that data type can be defined in any programming language. So abstract data type for Q, the instances will be ordered list of elements where one end is called as a front and other end is called as a back. So you will have a list where you have front and back pointing to that list. Where the operations are empty operation which returns true if the queue is empty, otherwise it returns false. Size will return the size of the queue. Front will return which is the element at the front but does not remove the element. Back returns the last element in the queue but does not remove the element again. So here pop will actually remove the element. So pop is removing means deletion. Deletion always happened at the front. So it removes the element from the front of the queue. Push means insertion. So insertion happens only at the rear end. So add the element X at the back of the queue. That means at the rear of the queue. So this is the abstract data type. Now what are the operations that are applied on the queue? So the basic operations are enqueue. That means inserting the element into a queue. So it is inserted at the rear end. Dequeue means deleting the element from the queue. So it is deleted from the front end. Peek. Peek means reads the element at the front. Okay. So it is reading the, that means you can call it as a front element. Okay. So peek means it gives you the front element, but does not remove the element. Is full will tell you whether the queue is full or empty. And then is empty checks if the queue is empty or not. Now, what are the queue variants? So we have 4 variants of a queue called as a linear queue, circular queue, priority queue, and double-ended queue. So today we'll discuss about the linear queue and the circular queue, and in next session we'll discuss about the priority queue and the double-ended queue. So about the linear queue. So linear queue, you can see here with the array representation will look like this linear queue. Right now we have the 10 elements array here, but we have only 7 elements stored, but total it can store 10 elements. Okay, not 0 to 7, 8 elements have been stored. So where front is pointing to the element 3, which is stored at the 0th index. Okay, and rear is pointing to the index 7, where the 30 is stored. Now how does the remove operation happens here? So remove operation is done at the front end. That means 3 will be removed first here. So when 3 is removed, front is incremented and it is pointing to the next element. So again, if you call remove operation, 15 will be removed. So 15 is deleted, and you can see front is incremented to the next location. So like that, you can remove 7, front increments. Again, remove operation will remove at the front, that is 8 is removed. Okay, and front is pointing to the next element. Again, remove operation. So 9 is removed, front is pointing to the next element. So now you can see after deleting 5 elements, front is pointing to the element 10, which is at the index 5. Rear remains same. Rear won't change. Okay, it remains same in the remove operation. Now, what is the insert operation? Okay, how does the insert operation happens? Insert is always done at the rear end, and you know at rear there is a enough space to be inserted. So 2 values can be inserted here. So it is inserted at the rear end. That means the element is inserted at the index 8, so it is inserted here. So when the element is inserted, for example 50 is inserted here, rear will increment by 1. So next element, it can be added to the index 9. So here this space is there, so element 40 is added here. So when 40 is added, rear will increment here and it is pointing to that element. So always rear is first incremented and then the element is added. Okay. So rear incremented to 9 and the 40 is added here. Now if you, when the 40 is added here, so what happens? When 40 is added, the queue becomes full. Okay. Now if you try to insert one more element, what will happen? There is no space to insert. Yes. So it is called as a overflow. Okay. Whenever you try to insert in a queue full, it is called as a overflow. You cannot insert when the queue is full. So if you want to create a queue, how the code can be written? So code can be hash define max of 5. That means we can have a queue of 5 elements. Okay. Just we have declared the 5, where queue can be created by declaring int queue of max. Max is 5. So queue is the name of the array. So this queue is the name of the array. So this queue is created with 5 elements. And initially front and rear will be -1. Okay, front and rear both will be pointing to -1 here. So this is the initial. Okay, that means queue is empty here. Now how does the insert operation happens here? So for insert operation, it will check first whether the queue is empty. If the queue is empty, then rear and front both are incremented to point to the next element. Okay, both are incremented when the queue is empty. So for example, I want to add a value here. So rear and front both are incremented here and the 10 is inserted. Okay, so rear is also 0, front is also 0. They are pointing the index 0, 10 is inserted. Now again further insert operation if I do, now queue is not empty, so it will go to the otherwise condition. In the otherwise condition, the new element can be added only to the rear end. Okay, so add to rear only. So how to add to rear? You have to increment rear by 1 and you have to add the element. So rear is incremented by 1 and 20 is inserted. So if I want to insert one more element, so rear will be again incremented and again one value is added, 30 is added here. So again rear will increment, 40 is added. So again rear will increment, 50 is added. Now what happened? Queue is full. Okay. So when you add the last element, the queue becomes full. Any further additions will be overflow. So what is the condition for queue full? Condition for queue full, you can see when the rear value and max -1 value both are same, then we can say queue is full. Okay. Rear is exactly same as max -1. Both are pointing to 4 here, index 4. So the code, if you have to write the C++ code, then how will you write the code? So we'll discuss the different situations. First situation, when the queue is full and you are trying to insert 80. Okay, for example, in this diagram you can see max -1 is 4. Okay, and this is one situation where front is pointing to 10, which is at the index 1, and rear is pointing to 40, which is at index 4. That means there is no space for addition here. So rear value is exactly same as max -1. That means queue is full. Okay, condition is true. So already we said condition is what? Rear and max -1, if both are same, the queue is full. And when the queue is full, any further addition should be overflow. So as soon as you try to insert 80, it comes and checks the first condition. What is the first condition? Is rear equal to max -1? So you are checking the condition here. Okay, so what is the condition? You are checking is rear equal to max -1? Yes, rear value and max -1 value both are same. So condition is true. So you will get the message overflow. Okay, you get the overflow message. Next, this situation so is handled correctly in this code. So next, situation 2. Situation 2 is suppose queue is empty. Okay, queue is empty means we have shown two outputs here. One is before inserting a 10 and one is after inserting a 10. So two situations are there. So how does it work for this situation? When the queue is empty, so then the rear and front both will be -1. Okay, this is very important. Front and rear both are -1. So first it checks the condition. Is rear equal to max -1? So as rear is -1 and max -1 is 4, hence condition is false. So rear is here -1 and max -1 is 4. Condition is false. So it will come here. It checks. is front equal to -1. So front is -1, condition is true. If the condition is true, it will increment front by 1. So front is incremented by 1. So what is the value of front here? -1. So front will become 0. So you can see in the after insert, front is pointing to 0th index. So front is incremented by 1. Then it will go to the next code, that is it will go for inserting the element. So item is added into queue at what location? Plus rear. Plus rear means what? It is a pre-increment. Pre-increment means rear is first incremented. So what is the value of rear here? -1. So my -1 plus 1 will be 0. So rear is now pointing to 0. So both rear and front both are pointing to 0, and it will become q of 0 equal to item. So item is say 10. So 10 is inserted here. Okay. So here this code actually inserts the data, and after that again it checks, is rear equal to max -1. So is rear equal to max -1? No, condition is false. Okay, so it comes out. So here this code here is responsible for inserting the data when the queue is empty here. Okay, so further next situation. So in the next situation you can see that the you can have the situation like front is somewhere in between and rear is also somewhere in between, but front should be in the beginning and rear should be after. Okay, so in this situation, so before insert 40 we have shown the situation here where front is pointing to the index 1 and rear is pointing to index 3. So this is rear value and this is the front value. So front is storing 10 and rear is storing 30 at the indexes here, whereas max -1 is 4. So first condition it will check, is rear equal to max -1? So rear is 3, max -1 is 4, so condition is false. Then it will check this condition, is front equal to -1? So front is 1, so condition is false. So it will go and insert the element here. How to insert the element? Increment rear by 1. Okay, first rear is incremented, so rear will become 4. Okay, rear will become 4, and this element is inserted at the index 4. So q of 4 equal to item. So this is how the element will be inserted here. Okay, so after insert the situation, so this you can see after insertion the rear is incremented by 1 and the element 40 is inserted here. Okay, and after insertion again it will check the last condition, is rear equal to max -1? Okay, so is this condition true? You can check here. What is the rear value? Rear value is 4. Okay, what is max -1? Okay, max -1 is same, max -1 is 4 only. So max -1 is also 4, rear is also 4. If both are same, so it will display the message q is full. Okay, it will display q full. If you try further addition to this, then this condition will become true and you will get overflow message in the further additions. Okay, so that is how the insert function here works. Now here situation, fourth situation here. Okay, so you are inserting 60 when the queue is full. So it is like same. Okay, rear and max both are same. So rear equal to max -1 condition is true. So you will get a overflow message here. Now display function. Suppose you want to display the queue. Okay, how will you display the queue here? So in that display function, you are first checking, is a queue empty? Because if the queue is empty, you cannot display anything. So it is checking whether the front is -1. So condition is false for this example. Okay, if queue is empty, the condition will be true and it will display empty. Right now condition is false. Then it will go to the for loop. I will start with the front. That means this will become I. Okay, this will become your I, and this I will be incremented each time by 1 till it becomes equal to rear. Okay, so this is your rear. So last value of I will be 3 and I starts with 1. Each time you are going to display q of I. So q of I means first q of I will be displayed as 20. Okay, next I will be incremented by 1. So I will become 2. Okay, I becomes 2. Then q of 1 will be displayed as 30. Then I is incremented by 1. That time it will become equal to rear. Then it will display 40, and again I plus plus. If you do this, condition becomes false because I will become 4 and rear is 3, so it is not less than equal to rear. So condition becomes false. So it will display all the 3 values here. Okay, so this is how the display function works. Now remove operation. Okay, so today we will only discuss about the linear queue. Okay, tomorrow we will discuss about the next one, that is a circular queue. So here remove operation, how does the remove operation is done? So this is one snapshot of the queue where front is pointing to 0 and rear is pointing to fourth index. So 0th index and fourth index, and the values are 10, 20, 30, 40, 50. And you know remove is applied where? It is always applied at the front end. So we'll see how it is done. So remove is from front end. So it will remove from the front end. That means this 10 will be removed first. Okay, so you can see here element 10 is removed. So before you remove the element, store that value into some variable. So you may need this for future use. So store it here, and then the front is incremented by 1. So element is removed. Again, if you call the remove operation, again this 20 only will be removed, because remove is always from front end. So you can see this front is incremented by 1 and the element 20 is removed, that is stored. Again, if you call remove operation, so again store 30 into the variable and front you have to increment here. So 30 is stored in the variable, front is incremented by 1. So again the remove operation, 40 is removed, front and rear now both are same. This is important condition here. Now when front and rear both are same, you can say there is only one element in the queue. So this is our condition to check. Okay, when there is only one element. And when there is only one element, and if you call the remove operation, the queue has to become empty. So this is your condition. When front and rear has only one element, you have to set the queue to empty if you call the remove operation. So how to set to empty? Both should become -1. So here you can see if the last item is removed, initialize queue to empty. So this is the last item. So initialize queue to empty. So how to initialize? Front and rear both should be set to -1. So queue has become empty now, and the last element is removed. So the code, see this is the code. Situation 1, queue is empty. Okay, this is situation 1. When the queue is empty, what are the values of front and rear? Both are -1. So here you are checking, is front -1? Yes, condition is true. Condition is true means can you remove the element? There is no element to remove. Hence it is underflow. Okay, this is called underflow, and it will stop. It will not execute further. Then next situation, situation 2 is front and rear both are same. That means you have only one element. If both are same, only one element. So this is before remove. So before remove, if there is only one element, you have to set the queue to empty. Okay, that means after removing 50, front and rear both should become -1. So you can see in this diagram, right? So here both are same. Okay, both are same. Here front and rear. After remove, front and rear both should become -1. So how it is done? First, it will check this condition. Is front a -1? So what is front value here? Front is 4. Okay, front is 4 here. So condition is false. Then before remove, you have to read the element. So you are saying Q of front will be stored in the item. So what is Q of front? Q of front is 50. So 50 will be stored in the variable. Then you are checking, is front and rear both are same? Both are same means what? You have only one element. So condition is true. So this condition is true. If this condition is true, you are setting front and rear both to -1. Okay, that means you have set this. Front and rear both are set to -1. And Q has become empty. So you have to display the message. So Q has become empty. And because if condition is true, it will not go to else. It will come to the last statement and it will return the element that has been removed. So this is how the remove operation will work for front and rear when both are same. Okay, one more situation we'll see. Situation 3, front is at ith location, okay, and the rear also at some ith location. But here front should be less than rear. So front is pointing to some element 20 and rear is pointing to some element 40, okay, which are at the index 1 and 3. So it will check the condition first. What is the condition first? Is front a -1? So condition is false. Front is 1, condition is false. Then you are reading the element before remove. Okay, so what is the element? Element at front. Front element will be removed. So that is 20. So you are storing that 20. Okay. Then you are checking, is front rear both are same? So rear is here and front is here. Both are not same. They're different. So condition is false. So we'll go to else. So in the else, when these all conditions are false, that means you have to remove the element from the front. So how to remove the element from the front? Increment front by 1. Okay. So when you increment front by 1, it's like element is removed. Okay. So that is how. So what is the element that is going to be removed here? So 20 is going to be removed here. So you can see 20 is removed, front is incremented by 1. So finally you are returning the element that has been removed. So this is how the linear queue works. So here we will take a break. In the next session, we will discuss the circular queue. Okay. And in next session, we are going to discuss the priority queue and the double-ended queue. So thank you all for patient listening.